All right, let's take a look at our lesson on systems of linear inequalities. So this particular lesson, we're going to be graphing inequalities. And if you recall, on the previous lesson, we graphed, they were just lines, right? They're just x is less than, negative 3/2 and x is greater than negative 1/4. Just lines on a number line. Here, we're actually going to be in two dimensions. We have x and y, so we're going to be graphing these inequalities on basically the coordinate plane. The easiest way, not the best I guess, but the easiest way to graph lines would be to get them into the form y equals mx plus b, or equals or less than or greater than mx plus b. So that would be the easiest thing. So let's start with this particular one. We're going to graph this one in blue. So if you recall, the 4 is the y-intercept. So I would go up 4. Then my slope is -2, rise 2, run 1. Rise 2, run 1. Let's get our ruler out. So since this one doesn't have the extra equal sign, this line needs to be dotted. So this one is a dotted line. Okay. Now there's several ways we can decide what to shade. One way is to, let's just look at this one by itself. Let's not worry about the next line yet. So this tells us that y has to be larger than this piece. So we can look at that and know that this side is where we graph. So these pieces right here are not possible. Now, if that really troubles you, you're like, well, how do you know that? Then what we could do is we could choose a point. Let's choose a point that's definitely in here. So let's say 2, 3. Let's choose this point. So for the point 2, 3. So what we would do is we would take this point, we could do it in our head or we could write it down, and we sub it in for the x and the y in our equation and see if it creates a true statement. So I put a 3 in for y, greater than -2 times 2 plus 4. And let's see if that's true. Is 3 larger than -4 plus 4? And yes, it is. 3 is larger than 0. So we can see from that scenario that it's correct. We're not going to be shading anything underneath the line, just above the line. All right, so let's move this out of the way. Okay, so let's kind of, in our head, we know we're going to be up here. So the next line, we have a y-intercept of -2, and then our slope is 1. So let's draw that. Now this one has an equal sign underneath. It's greater than or equal to. So we need to be sure to do a solid line here. Okay, so we have a solid line. All right, so let's see, what do we shade here? So for this one, we know we're going to be up here, so this section is out and this section is out. We discovered that from the first inequality. So we really just have two different inequalities, right? This section, it's either going to be this section or this section that we shade. So one way to do that is to look at this at y has to be smaller, so it needs to be under the line, which means that it would be this section right in here. Now let's say that bothers you. You're like, I'm not really sure about that. What you could do, again, is you could take a point. Let's see, 1, 2, 3. Let's take this point right here. Let's take the point 4, 0. And we plug it into this second line. So 0 less than or equal to 4 minus 2. Is 0 less than or equal to 2? Yes, that's true. So that's one way that you can determine, or actually a couple of different ways you can determine what to shade. Let's say you don't want to do one line, by itself. So let's say you want to just graph both lines and then figure out which of the 4 sections need to be shaded. And again, what you could do is you could choose a point. We'll choose the, keep the point 4, 0. And we'll see that this makes both inequalities true. So the first one, 0 greater than negative 2 times 4 plus 4. So is 0 greater than negative 8 plus 4? Yeah, 0 is greater than negative 4. So we can see that that point satisfies both inequalities. Okay, so a couple of different ways to determine the shading. All right, so let's go to our second and final example. Here, again, if it's not in this form, y is less than or greater than mx plus b, then you should get it in that form. You should do algebra and make it in that form. It's already in that form for us, just because this is an example. We're just working through to determine how to do the inequalities, so not the graphing of lines. All right, so we would start with a y-intercept of 1, and then our slope is 1. So let's see, this is going to be a dotted line. So let's get our ruler. Okay, so this is going to be a dotted line. All right. I like to, instead of picking points, I like to think about the y being bigger. So that means that our answer is going to be in this area above it, above the line instead of below it. So I'm not going, these parts down here, the answer is not, or the shading is not going to be down there. This second one, absolute value of y is less than or equal to 3. Let's remember how we worked with our absolute value inequalities. Remember, this less than is an and, so I can translate this as negative 3 less than equal to y less than equal to 3. Now, that kind of gives us a bit more information. I would need to look at negative 3 is less than equal to y, and y is less than equal to 3. So if we just look at the equal part, y equals 3 and y equals negative 3, that tells us where our line would be. So we need a line at 3, and it's going to be a solid line. And we need a line at negative 3. Okay, so we have both of our lines. Okay, it's a less than or and, so both scenarios have to be true. We need to see where would it be true that y is smaller than 3 but larger than negative 3, and that puts us in between. Okay, so we're in between. So we talked about this particular inequality. We know we need to be above the blue line, but we need to be between the pink ones. So that gives us this particular area right here. This is the portion that would be shaded. All right, and that concludes our System of Linear Inequalities lesson.